So in this problem, we have 2SO2 plus oxygen gas going to 2 molecules of SO3. The equilibrium constant is 5.60 times 10 to the 4. Very, very large number. So the equilibrium favors the product side because of this magnitude. 10 to the 4 is a very, very large number. So the initial pressures of the SO2 and O2 are 0.350 atmospheres and 0.762 atmospheres. We quote the equilibrium constant at a specific temperature. So at a different temperature, we will have a different value of K. And products over reactants is the equilibrium constant, each raised to the stoichiometric coefficient. So the question here is, when it reaches equilibrium, will the total pressures, this plus this, be the final equilibrium pressures of these guys? And the answer is, will it be equal to this, will it be less than this, or will it be greater than this? And the answer is that it's going to be less than this. The reasoning why it's less than this is having to do with the magnitude of this equilibrium constant. See, it's overwhelmingly favoring the product side, and there's 2 moles in the product side. The reactant side, there's 2 plus 1, 3 moles. So going from 3 moles to 2 moles implies less pressure. So there's going to be less pressure when this reaction settles, when this reaction is completed. It's not 100% products, nor is it 100% reactants. It's some combination of reactants and products when the reaction is complete. So will the reactants be more? Will the products be more? If the equilibrium constant is 1, then the reactants and products will be equal to one another in terms of their pressure or concentration. Since we're talking about gases, so it's also a pressure, or it could be concentration. So we're going to 2 moles, and that is less than 3 moles, so we would expect the equilibrium pressure to be less.